So here we have to solve this question by using first principle. The question is x plus 1 upon x minus 1. Fourth question, fourth part. Now we know what is first principle. Whenever we are finding out the derivative is equal to limit h tends to 0 f x plus h minus fx upon h. Right? So fx means the function which is given to us. X plus h means wherever there is x, we have to put x plus h. So we are putting the values here. Fx plus h means x plus h plus 1 and x plus h minus 1. In place of x, we have put x plus h minus fx, that is the function itself. X plus 1 upon x minus 1 and upon h. Right? Now for simplification, we will cross multiply the results. Let's cross multiply. So let's take it as x plus h. X plus h plus 1 into x minus 1 minus x plus 1 into x plus h minus 1. And in the LCM it will be x minus 1 into x plus h minus 1. X minus 1 into x plus h minus 1, and there is h also. Okay, don't forget to write h. Now we are multiplying. See, no need to multiply each and every term. How are we multiplying here? We are taking x with x plus h, x with 1. Then minus 1 with x plus h and minus 1 with 1. So this way we are multiplying the factors. Limit h tends to 0, x into x plus h plus x minus 1 into x plus h minus 1. A negative sign is there. Whenever we are having some negative sign and we have to multiply some terms, always apply a bracket so that we do not make any mistake. So next, again we are applying this multiplication. X into x plus h minus x plus 1 into x plus h and minus 1 divided by that we are having h, x minus 1 and x plus h minus 1. Okay. Now we are opening this bracket, and after we open the brackets, the signs will change. Let's see what terms will cancel out. It is x into x plus h and minus of x into x plus h. Plus x and plus x we have. So this is 2x. Minus of x plus h and minus of x plus h. So minus twice of x plus h. Then minus 1 and plus 1. So this minus 1 and plus 1 will cancel. Divided by h, x minus 1, x plus h minus 1. Limit h tends to 0. Now we have to find out the complete derivative. Okay. So after this, now if we look here, again we multiply this minus sign inside, we get 2x minus 2x minus 2h. So this is limit h tends to 0, 2x minus 2h upon h into x minus 1 and x plus h minus 1. Now if we look at these two, so what do we get? Let's write it in next step. Minus 2h upon h, x minus 1. We always apply the limits whenever the some function is in its most simplified form. अभी ये पूरी तरह से simplified नहीं हुआ है. We can cancel this h, and now we can put h tends to 0. And now we are putting h tends to 0. So what do we get? Minus 1 upon x minus 1. This becomes 0. Again we are left with x minus 1. So we get the derivative as minus 1 upon x minus 1 whole square. Minus 2 upon, sorry, 2 is also there. So it is minus 2 upon, this is the derivative f dash x. Right? Yes, this is the answer. And we can check the result by applying formula also. If we apply the formula, that is quotient rule, and if by quotient rule we are doing the derivative, we will get the same result. Minus 2 upon x minus 1 whole square. Done? Now we are coming to miscellaneous exercise. So first question is using first principle. So you have to do it yourself. Very simple questions are there. And let's come to question number. We are taking fourth question. We use the let's assume the function as ax plus b into cx plus d whole square. Now see, if we look at this question, what do we get? It is product of two functions. Yes. So we have to apply product rule plus. Here it is cx plus d whole square. The chain rule will also be applied. So both product rule and chain rule. Let's take y dash. First function as it is. Derivative of second. Now when we are taking derivative of second, the outermost function that we have here is x raised to the power n. So by chain rule it is n x n minus 1. And whatever function we have inside, we have to take the derivative of that also. Cx plus d. What is the derivative of cx plus d? What will be the derivative of this? Cx plus d. C. Only C because a constant is there with the variable. So constant comes as it is. X ka derivative 1. D is a constant term. Derivative is 0. So this is C. Plus. Then second function as it is. Derivative of first. So derivative of ax plus b is a. Now if we can simplify these terms. That is, we can take some factors common. So Cx plus D is common. Let's take it common and we are left with 2C into Ax plus B plus A into Cx plus D. No need to further expand this. We can just write the answer in this form. Y dash. Okay. So you have to remember that in all such cases, you have to apply product rule plus chain rule also. बस you no need to further simplify this. क्या करेंगे? Just multiply तो कर सकते हैं. Nothing is common. So we will just leave it here. Now here, if we look at this, which rule can be applied here? Quotient rule. So let's apply quotient rule. We are finding out y dash. Square of the denominator. Denominator as it is. Derivative of numerator. क्या हो जाएगा? What will be the derivative of px square? 2px. Very good. 2px plus q. We have a minus sign in between, right? Then numerator as it is, px square plus qx plus r, and derivative of denominator. So what will be the derivative of denominator? A. Now you are getting it, how to find the derivatives. Okay? Yes. 2p, p will be as it is, x square ka derivative 2p plus q as it is, derivative of x is 1, r is constant, derivative is 0. And similarly for the denominator, derivative of ax will be a, derivative of b is 0. Right? Now we can simplify this. Let's multiply all the terms, and if some term will cancel out, we'll cancel that out. Otherwise, we can just leave it that way. So we are multiplying the factors. 2ap x square plus aqx plus 2bpbx plus bq minus, there's a minus sign, minus apx square minus aqx minus ra upon ax plus b whole square. Let's see if something is cancelling out. Plus aqx minus aqx. Then we have 2apx square and minus apx square, right? So it will be apx square. apx square. What else? Or nahi hai. So plus 2bpx plus bq minus ar upon ax plus b whole square. See, whenever we are simplifying, and after simplification, whenever we are writing the result, always just keep it in mind that when we write down the result, it should be in decreasing powers of the variable. Okay? That is why we have written it in this form. बस ये ध्यान में रखो कहीं भी, not only here, कहीं भी, but because these are some polynomial functions, so whenever we are writing down the polynomial, it is always written in decreasing powers of the variable. So first of all, x square wali term, then x wali term, and then the constant. Okay? Note it down. Yes, how will we solve this? We have to find out the derivative. What can we do for simplification? No need to take the LCM. It will make the question complicated. Rachit is correct. We can write it like this: ax raised to the power minus 4. एक ही तो वेरिएबल दिख रहा है हमें यहाँ पे, right? So we can take it in the numerator. We can write this as x raised to the power minus 4 minus b x raised to the power minus 2 plus cos x. Now this is a constant with the variable constant as it is, and x raised to the power n x n minus 1. Similarly here, constant as it is, n x n minus 1. And what is the derivative of cos x? Minus sin x. C always negative, right? Minus sin x. So we have, now we can take the powers positive, right? Write it in the denominator again. So minus 4a upon x raised to the power 5. This becomes plus 2b upon x cube minus sin x. No need to further simplify this. Don't take the LCM, right? No need, yes. Leave the answer here. Not enough. Any problem in this?
No.
In this, again, what type of functions do we have here? N and m is there in the power. We have product of two functions, right? But since we are having some power also, so it is x raised to the power n. That form is there. So we have to apply both product rule and chain, right? So if, see, you can write down one more step so that you may not confuse that where to apply product and chain rule. First function as it is, you can just write down this step also. Derivative of second. So that you won't forget anything. Plus. First function as it is, derivative of second, plus second function as it is, derivative of first. ठीक है, अगर हम ये वाला स्टेप लिखेंगे तो हम कुछ भूलेंगे नहीं. हाँ. Now you do the derivative. Ax plus b raised to the power n. Now here we have to apply chain rule. X raised to the power n है, nx n minus 1, and then the derivative of cx plus d also. As what is the derivative of cx plus d? C. So n x, x means this complete term, n minus 1, and derivative of cx plus d plus. Next is cx plus d raised to the power n, and same thing will be applied. Yes, same thing will be applied here. Nx n minus 1, nx n minus 1, and it is a. Now to simplify this, what we can do? How can we simplify this term?
Let's go.
We can take some powers common, है ना? We can take some factors common. So let's see what factors can be taken common. See here it is, we can take always the least factors common, right? Least powers. So least power here is m minus 1, and here it is m.
नीचे वाले में देखना पड़ेगा. जैसे ax है इसका ax है.
हाँ, और क्या? The base should be same. वही तो factors common ले सकते हैं. यहाँ power is n and there power is n minus 1. So we can take ax plus b raised to the power n minus 1, cx plus d raised to the power n minus 1. ठीक है, बाकी तो कुछ नहीं कर सकते इसमें. Now we can write MC into whatever is left we will write there. So MC, and if we take n minus 1 common from here, what power is left? Let's look here. X raised to the power n है, ठीक है. We are taking n minus 1 common. तो क्या लिख सकते हैं? What is left?
n by 2.
No. Let's look here. And it can be written as minus 1 plus 1. Can we write it like this? Right? And we are taking, we can write it like this also. N minus 1 into x. Yes. If base is same, we add the powers. और अगर ये addition की form में लिखी है, तो we can separate them like this. And we are taking n minus 1 common. What is left? Power 1 is left.
So ax plus b.
Ax plus b is left. That means ax plus b is left. Plus and a into here cx plus b is left. ये बात clear हो गई? When we are taking n minus 1 common, the power was x raised to the power n. If we take n minus 1 common, तो plus 1, मतलब minus 1 plus 1 ले लिया, तो plus 1 will be left. And further we cannot simplify this, so leave the answer here only. This is y dash. And in the final answer you have to write y dash. Chalo, let's take question number 17. Y equal to sin x plus cos x and sin x minus cos x. We have to find out y dash. So if we look at this function, we can see that it is in the form of u upon v, where u and v are functions of x. So we can apply quotient rule, right? So in quotient rule, square of the denominator, sin x minus cos x whole square. Denominator as it is, derivative of numerator. Now we are doing the derivative. Since it is addition of two functions, so we can take the derivative separately. Derivative of sin x,
Ma'am, d by dx
cos x. Derivative of cos x, minus sin x. We have a minus sign in between whenever we apply quotient rule. Then,
Ma'am, I checked it out. And d by dx sin x.
bilkul, you can do it that. Numerator as it is, derivative of denominator. Now denominator is this, derivative of sin x, cos x. Derivative of cos x minus sin x, और एक minus पहले से भी है, so it becomes plus sin x. Now we will multiply all the terms. Let's see क्या कोई cancel नहीं हो रहा. But if we see here that if we are taking a minus sign common from here, so this becomes whole square, right? Minus, and we get sin x minus cos x whole square. Minus, this is sin x plus cos x whole square. And we have sin x minus cos x whole square. क्या? No, if we have a minus sign in between, you cannot cancel it like this. ठीक है? No, do not cancel. You generally make students make this mistake. ये cancel कर दिया.
Multiplication में.
कहाँ है multiplication में? There is a minus sign here,
How common here?
right? So we first of all have to open the whole square. Minus sin square x plus cos square x minus 2 sin x cos x. Minus sin square x plus cos square x plus 2 sin x cos x. That is a plus b whole square and a minus b whole square. Now let's see what terms are cancelling out. It is minus sin square x. If we multiply this minus sign inside, this is also minus sin square x. So minus 2 sin square x This is minus cos square x and minus cos square x. So minus 2 cos square x. This is plus 2 sin x cos x and this is minus 2 sin x cos x. तो ये वाली टर्म कैंसिल. ठीक है? This is left. And see what we can do here. We can take minus 2 common and sin square x plus cos square x is left. What is sin square x plus cos square x? 1. So let's write it in the next step. Sin x minus cos x whole square and this is minus 2 into sin square x plus cos square x upon sin x minus cos x whole square. So we get minus 2 upon sin x minus cos x whole square. And we never expand the denominator. No need to expand the denominator. It will always be in terms of factors only. Right? कोई जरूरत ही नहीं है expand करने के denominator को. Factor की ही form में छोड़ते हैं. कहीं पे भी whenever we are simplifying something, denominator always should be in factor form. Right? So this is the answer. Minus 2 upon sin x minus cos x whole square. So rest questions which are left, we will do them tomorrow. And tomorrow we will complete this exercise.